Okay. All right. So this is one of three. Okay. We'll give everybody a couple minutes to show up. I'm going to let this one record. Even if it's dead air, I'm going to let this one record, because if I stop it, if I pause it, chances are I'll do the same thing as during the lecture.
Hey, Dr. Bly, I have a question.
Certainly.
How long are you wanting us to stay in here?
This is voluntary.
Okay.
This course, right, the lab course is completely web-based. I just thought it would be nice if I gave you some similar instructions to the Chem 101 on how to navigate, what's expected, and that, so forth.
Okay.
And then, yeah.
Are you going to go over how to set up the lab notebook over Zoom, or do you just want us to go off of your diagram or whatever you posted on Blackboard?
Yeah, I can show you. I'll give you some details. Yeah.
Okay. And I was just wondering, because I'm going to have to get out of here about 2:30 because I got to go to work.
That's fine. This one, I guarantee this one's recorded.
It is. It's recorded.
Yeah, I'm not stopping the recording on this one. Okay. So in the interest of time, I'm gonna go ahead and get started. And to do that, I'm gonna share Blackboard. I think I'll do it that way. So let me pin myself. There we go. And then I'm gonna go share. Let's see. I think it's this one. Right. I need to go back. Let's see. I need to go back here. Let's see. Blackboard. And let's just go all the way back and work our way into the course. Here we go. Okay, so this is what the Blackboard course looks like for the lab. Let me also make it, let's see, student view. Where's the student view? Am I going to have to stop share? I'm going to have to stop share. Sorry. There. And now I'm going to reshare it. Share. And I think it's this one. There we go. Okay, so this is what you guys are going to see. It's got start here, like always. It's got New River email. I'm not sure that's working very well yet. I've got some extra stuff here where you don't have to go digging for it. How to start and keep a lab notebook. Actually, these might be different from one another. That's not the best one. Let's go back. Okay, this one takes us actually into the course itself. Okay, so we're going to get there in a minute anyway. So let me go back. All right. So here's start here. Notice we've got syllabus here. All right, so there's your syllabus. There's my schedule. Before I dig into the syllabus, let me go look at some other things. Here's items on safety. Since we're not going to be in the lab and this is not graded, safety rules. I'll just let you review the safety rules on your own. And I suggest you do it, because if you're going to get a job in an industry that requires knowledge of chemistry, then you're going to have some inkling of what safety is constituted. So you ought to look at those. The safety contract and the rules. Also, you need to know something about safety, because the report, when you do a formal report, one of the components in the formal report is a section on safety. What safety issues were considered in the performance of this lab. Right? If you leave that out, then you lose points in the rubric. So you probably ought to review that. So that's safety. Here are the lab exercises. We'll go into those in a minute. Here's the folder for the lab notebook and how to do the reports. Okay. So I got a lot of red ones. The red ones are the ones you need to pay close attention to. Lab report instructions are here, right? So this says you need a title page. Now, these conditions, these fonts and things like that, those are variable. You need a title page and the information that goes on the title page in a formal report. I've got an example that I'll show you. So just read through this and then take your example and key off the example. Okay. The body of the report has a blurb on objectives. Why are you doing the report, or why are you doing the experiment? Then what materials are required? That includes both reagents, that is chemicals, and equipment. Right, so you need both in materials. Then there's your safety blurb. Procedure. What procedure did you use to conduct the experiment? Now, when you look at the hard copy of an experiment, it's going to say, do this, do this, do this, do this. And that's the way you put it into your lab notebook. 1, 2, 3, 4. This is what you do step by step. When you write the report is after the fact. So it has to be in the past tense. And it needs to be passive past tense. This was done. And that sample will also help you with your wording. Then data. What did you collect? Observations, numbers. Put them in some sort of format that is easy for your reader to discern. Tables are good if you don't have a lot of numbers. If you have a lot of numbers that are difficult to decipher, you may want to build a graph, a visual representation of your data that illustrates your point, tries to convince the reader of your conclusions. Then you'll have a section with calculations. That shows me and the reader that you know what you're doing. In other words, you took that data and you did something with it. What did you do with it? And can I follow you through your calculations to know that you did the right thing? Because if your calculations are wrong, then the rest of the value of your report is garbage. Then the hard copy of the lab may have, doesn't always have, but may have questions that have to be answered. Right? So you put them in a separate section. And some of the questions may have already been answered by doing calculations or setting up the experiment, whatever that happens to be. If the question's already answered someplace else in the report, all you have to do is for that question number, say, reference, page number, section, where to find that answer. You don't have to duplicate it. And then all of your reports have a conclusion and summary. So you're going to have a summary of what was done in the experiment, and then what were the conclusions that you can draw from the experiment. And that may also include, for extra points, a real-world application. Where can this experiment shed light on something in the real world. Okay, so that's the basic structure of your lab report. And that would also be a rough structure for filling in your notebook. So if you set up your notebook correctly with this information, then you should be able to take your notebook, turn to the experiment, and write the report from the notebook. You don't even have to look at the hard copy. Now this is for formal reports, right? You've got a couple of informal reports, and this doesn't apply to them because on the informal reports, you just take the hard copy, you fill it out, answer questions, turn it back in. But for formal reports, you're going to have the information in your lab book, and you should have enough information in here that you can write the report from the lab notebook. If that's not the case, if you can't do that, then you didn't put enough information in the book. Okay? And I see that a lot with students that they don't even fill out their lab notebook till the last 2 weeks of class because they know it's going to be graded, right? And it shows. It's a pretty ugly scene. Okay. Now, let's see. Let me back up and look at, here's the rubric for evaluating your formal lab report. Okay. This is an earlier rubric, but it's built the same. I'll just substitute your course information up here, and when I get a copy of your report, I'll print it out and I'll put this rubric stapled to the front, and I'll fill in this information that's specific to your report. The nice thing about this rubric is it tells you what I'm looking for. Right? You want the most points you can get here, 12 points. If you can get 12 points in all these categories, then you'll get more than 100 points. It'll be more than 100%, and that's good for you. I got a separate rubric here for the first lab. The first lab we're going to do is learning how to use Microsoft Excel to help you manipulate data. Because when you get a lot of numbers, doing all those numbers by hand in a calculator can really be cumbersome, and Excel is an excellent tool for manipulating data. So that's what this one applies to. In fact, since we're on the topic, our first lab is going to be learning to use Excel for chemistry. If you want, since the schedule for labs places Excel in next week's Thursday, what we can do is meet again at 2 o'clock and actually go through the lab in this format. Since everybody's not here, you know, it's kind of what I'll do is send an email. I'll send everybody an email and say, if this is what you want to do, then I will schedule a Zoom session for that first lab, and we can walk through it.
I like that idea.
Okay. Okay. I'll do it anyway, and I'll issue an invitation to the rest of the class if they want to show up. There it is. Okay. So let's see. Before we get to reports, we probably want to look at notebook. How to start and keep a lab notebook. Let's see. Well, I'll tell you what. Let me just explain it using this notebook. Okay. So you probably want to make my image a little bigger so you can see what I'm doing. But this is what your notebook will look like before you do anything to it. So ink only. You only use ink in a notebook. So what do? On the cover, you identify the course that it belongs to, Chem 101. when, fall semester, and whose is it, your name. Those are minimum information. You can put other information there if you want, but that's the minimum. Now, you're going to take the notebook, and the first thing you're going to do is open it up, and with your pen, start numbering pages. So in the upper right-hand corner here is a 1. Then you turn the page, that's a 2, and a 3. All the way to the end, I think there are about 200 pages. So what you'll notice is all of the odd pages are right-hand facing pages, and all the even pages are left-hand facing. Okay, that's important because you're only going to, initially, when you start filling out your notebook, you're only going to write on the odd pages, on the right-hand pages. So first thing you do is you want a table of contents. You can start on the first page, right? Table of contents. And then you just say, what's the name of the experiment? And over here, page number, that's where it starts. That's all you need, just the starting page. Because why? The starting page is where you start the experiment, and then you're going to proceed, right? Proceed. And you're going to finish using all the pages you need on that first experiment before you get to the next one. When you get to the next one, you'll maybe skip a page and start on a new page number. So when you start your new experiment, you go back to the table of contents, write that one, starting page. Okay, that's why you only need the starting page.
So can we use front and back for one experiment and then just always restart on the right-hand page?
Now, initially, you want to fill in the right hand only when you're putting in information for the experiment.
Okay.
Just do right hand only. Leave the left hand alone. And I'll tell you why in just a second. Let's say you've got things in here. You've got the title, you've got the objectives, you've got materials, you've got safety information. Then you might have to go to the next page. And you create places for data, numbers that you're going to collect during the experiment. So you have maybe, this is the weight of the crucible, and you have a blank and put a little g out there for grams, right? That's where that data goes. Or you can create a table and have blanks in there for data. You need to do it that way because when you start conducting the experiment, and of course this is hypothetical, if we were actually in the lab, you would be doing the experiment and you may be working right along, merrily along, and you come down to the bottom and you say, uh-oh, there's some blank space up there. It's supposed to be a number there, right? You think. So you go back and check yourself before you proceed any further and say, wait a minute, is there supposed to be a number there, or did I skip that for a good reason? If you skipped it for a good reason, just draw a line through it. If you didn't skip it for a good reason, and you're supposed to have a number there, either you can get that number now, or you got to start all over again. But it's better to start before you get to the end, in the middle, restart, than to go all the way to the end and realize you don't have the information you need to write the report. So that's why you need to build in data tables or some type of data structure with blanks where you know you're going to put information in. And then you're going to take that information and do calculations. Okay. Maybe well, nearly always, information you gather during an experiment is not the end of the experiment. You've got to do something with those numbers. And many times you have to do calculations. Then you're going to answer questions, right, that come from the hard copy. And then you may have make your summary and conclusions. Right? Now, what if you want to draw a graph? Well, you won't know that you can draw a graph or you need to draw a graph until you got the data and you've already filled in your spaces here with information. Where do you put the graph? Well, put it on this side. So that's why you leave this side alone. You can put a graph in there, or if you make a mistake in setting up your experiment, you need to reword it. Or you change, or the instructor changes something in the middle and doesn't tell you until you walk into the experiment. Then you draw a line through the error and write what it actually should be. That's why not only do you leave this page alone, when you write things here, leave blank spaces between them, right on every other line. So for small errors, you can just draw a line and correct it. For big errors, you draw a box around it, a big X, and then an arrow pointing over on this side, and then you write in what it should be over here.
So they're just our plan B pages, basically.
Right, right.
Okay. Yeah.
Okay, so each experiment's going to be like that. And if you do it correctly, like I say, you can take this, write your report. It'll be painless because you've done all the work ahead of time, and the report is a formality. Okay, all you have to do is be sure that the wording is right for the procedure. So let's go back up and look at a sample report. Here's a sample. Let's see, is this the one I wanted? Yeah, I think this is it. Okay, so notice that this sample report has all the personal identifying information taken out. I checked with the student before I used it, and this person said, okay, and I assured them that I would take out anything that identifies them and use this as an example. So this is a really good report. Doesn't mean it's perfect. Right? There may be some comments that I make in there. I wouldn't be a good instructor if I didn't use some red ink. But you have your title page with the title of the lab. You have your name and any lab partners' names. Now, under these circumstances, you don't have lab partners. And even if we were to go into the lab under the corona hysteria, you wouldn't have lab partners because you'd have to maintain antisocial distancing. So this part, at least for this semester, you can leave lab partners out. Or you can put me in as your lab partner because I'm going to be providing you with all the information. Then this information is what course is it, what semester, where is it located? And then the date that the lab experiment was performed. You should be able to get that from the videos. I'm going to produce videos for each of the labs. And I should tell you what date it is. If that's missing, then you just say missing experiment date. But you will have a report date. So when you finish the report, that's the date you put on there. That's your title page. Then you start with objectives. Why the experiment? And what's required for the experiment? Safety concerns. Right? Now for the procedure, here is the proper tense for writing the procedure. The hard copy would have said, take a 2-liter bottle and do something with it. But you want to say a 2-liter pop bottle was obtained and was fitted with a cap with a valve in it, something like that. So the first sentence here is like, the local air pressure was measured with the barometer located in the classroom. Okay, so that's third person, passive, past tense. Third person means you don't say I and you don't say you ever. You say it or a proper name or identify what is the local air pressure would be the it. Was measured, or the mass of such and such chemical was, let's say, approximately 10 grams of sodium chloride was measured into a weigh boat using an analytical balance. Here's an example. Third person, passive, past tense. And number them, right? These are the steps that were done. Okay, see, there's some red ink in there. And if you're going to use Microsoft Word or some word processing program, they all have built-in spell checkers. At least use the spell checker. It may not catch all the errors, but it'll catch most of them. And then if it doesn't recognize a word, it'll flag it, and then you can check it yourself. I mean, those are the easiest points you can make, is proper spelling, and you'll notice the rubric counts off for spelling. So losing points for spelling is just stupid. Okay, here's the data. It's presented in tabular format, right? It's identified. Each column of data is identified with what is it, what are the units of measure? What is it, what are the units of measure? Right on down the line. That's your data. Now what do you do with it? Right? There were transformations that had to be done, right? And in the process, the student took the data and plotted it using Excel. So that's, you can get a nice graph and label it, and it looks great. There's another one. A different set, a different part of the data was presented here, right? This one was a curve, this one was a straight line. And this experiment, we happened to get 2 trials out of it. That's just what happened for this experiment. All right, so we had that, more information. And then the hard copy requested another calculation. Pressure times volume would give you these values. So here are the calculations, and you don't have to show me every calculation. If the calculations are repeated time after time after time, like this one, where you multiply pressure times volume and you get these numbers, just show me how to get one of them. Or in this case, we had to do a conversion. We used conversion factor to go from a measured value of air pressure to a useful value of air pressure. In this case, pounds per square inch. Now, why did we do that? Well, for this particular experiment, we were measuring pressure inside a bottle using a tire gauge, right? And tire gauges are not calibrated in millimeters of mercury. They're calibrated in pounds per square inch. So we had to add the atmospheric pressure to what was measured inside the bottle, right? You can't add apples and oranges. So we had to convert the atmospheric pressure to PSI so that we could add it together to the measured pressure. That's what this calculation is about. This one shows the calculation of the inverse of a value. Right? So we've got all those different calculations, even some words of explanation if you want. And then questions. Right? The hard copy may have pre-lab questions. It may have internal questions to the method. It may have post-lab questions. Just identify what's what and use the numbering system that's in the hard copy. What you don't want to do is force your instructor to go hunting for information. Look at me as another scientist. You've just written a publishable report and you want me to understand what you're saying so that you can convince me of your position. If you just slap stuff on the page in hodgepodge, you know what I'm going to do it. First time I see it, file 13. I won't even look at it. So you want to think about your readers. What do your readers need to know, and what format would be best to convey that information to them? Okay, so once we get through answering the questions, then we get down to conclusions and summaries. So this student did a summary and included some real-world examples. They even went so far as to cite some external sources. This is not, you don't have to have external sources cited. If you use them, that's fine. This is what you would do in a publishable report. You know, you would have literature cited in your report or in your publishable article, but it's not absolutely necessary. All right, so that's the format of the report. And you can actually use this format when you construct your lab notebook. Set it up that way. That way, when you go to write your report, everything will be in the same order, and it'll be easier to pull it out, put it on paper. Okay, let's see. What else do I want to do? Let's see. I close that one, close that one. Let's see. I don't think I'll have any trouble, but I have had trouble in the past, so that's why I wrote this document on plagiarism. Because sometimes a student may not understand what plagiarism means in the sciences. If you're writing a history report or an English report, that's pretty simple. You just don't copy somebody else's words word for word. That would be plagiarism. But in the sciences, it's a little more, it can be complicated. So I wrote this document to give you an idea of what plagiarism means. Now, the absolute most foolish thing you can do is to pair up with another student in the class and copy their work into your report word for word. That would be just daring me to do something about it, because it will be obvious. But read that at your leisure, and it give you some idea as to what we consider plagiarism in a lab report. Let's see. Now, when you're writing your lab reports, sometimes you might need to incorporate an equation or use special symbols or subscripts, superscripts, that type of thing. Microsoft Word has an equation editor built in, but this shows you it's usually not enabled when you first install Word or Microsoft Office. And this shows you how to enable it so it'll be available to you when you're writing your report. Okay, that's all that's about. Let's see. There's an example lab notebook. Let's see. Is that? Okay, I do have a sample lab notebook. All right, so this is what a student's lab notebook looked like. And good, I removed the personal information. And these are just some of the pages. Like there's a table of contents. Skip the page, go to the next odd. We're going to skip some more pages. There we go. So here's the first one. Right. That's what it looks like for this report. And this was very well done. Okay. We got some mistakes there, so we had to correct them. Right. You never erase in a lab notebook. You draw a line through it and correct it. Let's say you got a job working for a chemical company, and you're going to do research in their lab. You may not be the lead researcher. You might just be a technician. But you're going to keep a lab notebook at that company. And everything you do, what you do, and the results you obtain go into that lab notebook. Now, guess whose property that notebook is? It's not yours. It belongs to the company. So you need to write it in such a way that anybody that comes behind you, say you move on to greener pastures, a better paying job, and you leave that notebook behind, somebody else comes in on the entry level and they want to pick up where you left off. They need to understand, and you need to write legibly so that they can understand what you did. Okay, so there's your sample notebook. Let's see, some of these others are not necessarily, you don't have to use any of those. I probably should put that one in red. I was looking for, let's see, maybe I put it over here. Here we go. Extended character sets. When you're writing a report in a word processor for chemistry or physics or any of the sciences, sometimes you need special characters that are not on the QWERTY keyboard. So even as far back as before Windows, you may not remember these days, but we had an operating system called DOS, called Disk Operating System. Didn't have Windows. Everything you did was a command line operation. And if you needed to add a symbol, then it was kind of difficult. I mean, the learning curve was very steep. So then and following in Windows, extended character sets were developed. And you would use special combinations of keys. For all of these special extended characters, you would hold the Alt key down and type in a number on the number pad, not on the numbers across the top, but on the number pad to the one side. And you would get that character. So that's what this document is for. Okay, this gives you key combinations. Here's a code. So this one, let me see, can I make it bigger? No, not easily. So just download this and print it out. These are Windows characters, special characters. Alt key plus these, they all have zeros first and followed by 3 numbers. These are the DOS characters. Sometimes if one doesn't work, the other one will. So you have to try them out and see if they work. But these are the ones that I found useful for chemistry and physics. And these are for Windows-based or PC type computers. If you have a Mac, then these over here are supposed to work. I don't own a Mac. I just found these special character key combinations for characters. And you'll have to try them out yourself if you have a Mac and see if they work. But that shortens the time. If you're working along, writing out your report, you don't want to have to spend time to go to the character map, find the character, copy, go back to your document, paste. That's too many steps. With this key combinations, you can get that character immediately. Okay, so that's what that's all about. Let me go back. Okay, let's see. All right. So now, let me go back to, we skipped over the syllabus. And if you have a copy of the syllabus, I won't spend a lot of time in the syllabus because the format is similar to the lecture. All this stuff is the same. You'll still need your calculator, of course. You won't need a textbook or a bound lab book with experiments in it, because those are all delivered to you through Blackboard. That's what your notebook looks like. You can get it for less than $1 at Walmart. You need a lab coat. Well, you would have needed a lab coat. So if you're going on, you may want to invest in one when you have the time. Eye protection, you would have invested in some sort of eye protection. Let's see. Formal lab reports. Okay, here's how your grade is based. Lab reports are worth 60%. Lab notebook that I grade is going to be worth 20%, so it's not insignificant. Lab skills, that's a little more problematic because you're not actually going to be in the lab. So I'm going to have to come up with some sort of a measure of whether I think you're skilled enough. And that will be based on what does your report say? Did you use all the information that was given to you? Did you miss any important items, say in safety or whatever? So it's going to be kind of a guessing game. And here's the schedule. Okay, so the schedule in 101 has yellow highlighted exams. Those are when the exams are done. These yellow highlights are when you're actually going, when you would actually be going into the lab to conduct the experiment. So lab exercise 1 will be next week, and we're going to do that one in a Zoom session. Okay? Then the following week, we'll have laboratory techniques, Bunsen burners and measurements. That one, I've produced a
Now again, I'm with Disability Advisor regarding insurance, and my callback number is 866-201-7898.
I hate junk calls. Okay, so this exercise, I'll actually have a produced video for that one. Okay. So we won't have to meet in a Zoom session. I've already done one for this one, and Boyle's Law. So those videos are produced. I still got these to go. I've got a type of video produced for the rest of these, except that they're not actually in the lab. These guys, these first 3 after the Excel, they're actually in the lab, so you can see what I'm doing in the lab and gathering data at the same time. So I need to go into the lab and produce these. It's problematic now because the president of the college requires us to ask permission every time we want to go in the lab. And that's kind of a pain. Okay, so.
Does say no formal lab report. Does that mean we don't record them in our lab notebook, or?
Oh, that's up to you. I don't expect to see these first 2 in your lab notebook, but if they're there, that's fine. If you want to keep everything in your lab notebook, including these things, that's perfectly all right with me. But I don't expect it to be there, and I won't count off for not being there.
Okay, thank you.
Now, due dates, right? This is when you're going to, when you would have gone into the lab and done the experiment. Due dates are the next time that you go in to do another lab. So the due date for exercise 1 is on this date when we would be going in for 2. Or 2 would be this date for 3. 3 would be this date for 4, which would be actually a 2-week gap. This would be a 2-week gap. So that's been my pattern. If a report is due, is performed this week, it's due when we walk in the lab to do the next one. And we only have 7 labs, right? So it shouldn't be really that hard on you. The reason I used to put a lot of labs in here, but when I started doing formal reports, I thought you need more time to think about it and set things up and get things in proper order and produce a good report. So I pared down the number of labs to those that were just really essential for helping you with the lecture material. This last one has a due date that's independent because there are no more labs, so I had to put a due date in there for that one. Okay, so let's see, what other information is different than the lecture Well, we can't do makeup lab exercises because they're all going to be virtual anyway. There are no special quizzes or tests or exams in the lab. Just those things that were mentioned in the assessment in that table. Same thing for instructor hours. That's when I'm available. And the rest of it is pretty standard. The syllabus agreement, you don't have to do that one. I would suggest that you spend time digesting the information and keep a copy of the syllabus because you may want to go back and refer to it. Some of that information is duplicated in Blackboard. So let me see if I can find out I don't want to lie to you. Let's see, lab exercises. We haven't looked at this one yet. Well, no, I didn't put it in there. I thought I had put a schedule in here so that you could look. So keep your syllabus close by, and it'll tell you when each one of these suggested time to do those. All right. So I'll send everybody an email reminding them that we'll meet like we did today, next Thursday, and go over this one in person. And it'll be recorded. So if anybody has work conflicts or anything like that, babysitters or whatever, then you won't miss out on it because it'll be recorded. Just as this one is being recorded, I'm certain right now. Okay, so what do you have in each one of these folders? There's the special rubric for the Excel lab, right? And here's where you go in to get the hard copy. So you click on this one. You can get it from here, but to submit it, you need to go into this one. Then you have the ability to attach files, right? So when you complete the report, you can attach your completed file by way of this little dotted box. And then you go down here and, let's see, I've covered that, and click submit. And it'll show up in my gradebook. Let's see if we have any others that are, that may have different information in them. Okay, laboratory techniques. Right. For this one, we have, here's the exercise. Here's the demo, right? So this is a video. Actually, this is a link to my YouTube channel. That's where I put all my videos. So this links you to the YouTube, and that way you can look at it. This is a document. You can tell by the icon here. This is a document that gives you added information that goes with the video. I don't remember what it is. Let me see what it is. I was writing things down on my copy, hard copy. So this is information that I obtained during the process, right? So that's what you will put in your report. And then the other things, you have to actually calculate those to fill in those blanks. So don't think that just because there's a blank there that you can leave it blank. That's supposed to have something in it. Okay, so that's why I put that one there. Let me back up. And there's the YouTube video. Why don't I just click on it and see if it works? There it is. Okay, so if you click on that,
Here we are.
you'll get the video. Now these first videos, they're going to be kind of jumpy because I had some headgear, but I had my cell phone up here recording the whole thing. And my cell phone does not have image stabilization. So I tried to walk as smoothly as possible, but it's still going to be a little jumpy. Later videos, I've since bought an action camera, and all those guys have image stabilization in them, so those videos will be better. And if I get a chance at some point in the future, which won't do you any good right now, but remake the video in better quality. Okay, so that's the YouTube, and they'll all look like that.
Mr. Blah,
Yes.
when we get our notebook done, do we just scan that and send it in to you like that? Or can we actually just go in and just type it in there?
Oh, to submit your notebook for checking?
Right.
Yeah, you have to photograph it or scan it.
Okay.
The relevant pages, I should say.
Right. Okay. All right. Thank you.
Okay. That answers the question, where do I drop my lab report document? And these are all the possibilities. When you get down to these later ones, if for some reason I can't get to the producing the in-lab videos, this is what they will look like. Let's see, I think this one has a video. All right, so we're in my studio, and what I did was I went in and discussed the theory behind the principles behind the experiment, and then I described the process and the data that was collected all went up on that board, and then I described what to do with the data. So hopefully, if I get a chance to do the in-lab video, then this would be a supplement. It would be good to just at least look at the first part of it that gives you the theory, and then the rest of it you can stop it and go to the in-lab video. That's my plan. I want to get the in-lab videos done for all of my labs wherever I'm teaching. I'm doing some of them at Southern in Logan, so I'm making videos there, and I'm going to make, if possible, I'm going to make a video that's applicable for everybody. So if I do this have you do the same experiment at my students at Logan, do the same one as you do here, then I can make one video and just post it in all locations. That would be ideal. Okay. But in this case, I actually pulled out the data and put it in a more readable format. And sometimes I have clarification documents, things that help you with the calculations. Like this one, how do you do a calorimetry calculation where the heat of the reaction is important? It doesn't mean anything to you right now, but it gives you an example and walks you through the process. Okay. Okay, so let me go back and see. So there's our last one. So these last three, I don't have in-lab videos yet. But these first three, I do, and we're going to do this one in person next week. Okay, so what else can I say about this? I don't think of anything else unless we got some questions from the audience. But if you have questions, you know, I'm a text message away or an email away or a phone call away, and you can get an answer. I didn't check with everybody with 101. Well, yes, I did. I did tell everybody that you don't have to wait for any student support benefits in order to get in and start your Cengage homework. They give you a 14-day free trial, and I'm going to send an email to everybody with a blurb that was sent to me by the Cengage representative. So the wording will be right, and so that I think there's even a screenshot in there to show you where to go to get that free 14-day trial if you are unable to pay for the Cengage Unlimited at the moment. You can still get in there, and the free trial will also give you the textbook. So you don't want to be without a textbook. There's an electronic version that's available even with a free trial. Okay, so I'll do that. I've got to send 2 emails, one for the Cengage and one for the lab. And I'll do that as soon as we hang up. Any other questions? Okay.
No.
Everybody? Yeah, go ahead. If everybody's happy, I'm happy. So I'm going to stop the share and end the meeting, and we'll see you next Tuesday. Let's see, I'm going to stop the recording first.